target has reached for a package of some sort, and it appears he's going into the teacher's lounge. I'm going in for a closer look.
Be careful and good luck, Black Diamond.
Well, it looks like we have a bomb of some sort here. I'm going to send you a pic for identification.
I think it's a nuclear bomb.
Alright. Well, that's fine and dandy. Now tell me how to defuse it.
You'll probably have to solve a set of proofs. Just remember what your teacher taught you.
Alright, here they are. Alright, let's see. I got the givens down here, I remember that much. But I need to find another side. Those two sides are the same. These two sides are the same. Because of the givens. But let's see. Oh, I remember. These, pretty sure, are vertical angles, so they have to be the same. So yeah, so angle ABD is going to be congruent to angle EBC. I'm almost positive that's right. Vertical angles. And since I have that, I have all three sides. So for a triangle to be congruent, I have enough. And that's two sides and an angle. So that's why side angle side. So I can prove this now. Triangle ABD is congruent to triangle EBC by side angle side. And I use all three lines for this. Sweet. Hope the others aren't as challenging as this.
Okay, class, this is our next proof. This is type 2. First, what you've seen from the other ones is that you start with your given. So as you can see, I've already written down that segment AC is congruent to BC, and the M is the bisector of segment AB. Next, because of the midpoint being there, you split up AM and MB. So that means that segment AM is congruent to segment BM. And that is because of the definition of angle bisector. As you can see there, that is what you would put for that type of part. Next, because of the reflexive property, CM is congruent to CM. So you write segment CM is congruent to CM. Not MC, but CM. That is because of the reflexive property. Now that you have all enough sides or enough angles, you can solve the proof. So you write out what it tells you at the beginning to prove. then you figure out what sides or angles are available or what you've figured out. So you can see here that we have CB and AC are given sides, and then you have these sides. So that means that is side, side, side. Congruence property. And that is because of lines 1, 3, and 4, which you must list to solve your proof.
Alright, now I gotta do this one that's a little bit more tricky. I have 3 givens this time, so I got those down. And I guess we'll start by improving the givens. So right out it says these are right angles, so we know that, so let's go ahead and put those down. So I gotta put angle A is a right angle. And that's the definition of perpendicular angles. Yeah. I'll just abbreviate it to that. And that uses line 1 because it's using A. And then even our second given, I can do the same thing for line 2. So angle D is a right angle. And it's about the same thing. Perpendicular angles. And then we use line 2 on that one. And then all we have left, therefore if A and D are right angles, that means they're 90 degrees, that means that they have to be congruent. So I'm going to go ahead and put that. A is congruent. Angle D. And that's because all right angles are congruent. I'll abbreviate to right. And that uses line 4 and 5. And then let's see, just like in the last proof I did, we have vertical angles again. So angle ACB and angle DCE. And that's about vertical angles again. And then I think we have enough there because line 3 gives us a side, then line 6 gives us an angle, and then that gives us an angle. So that gives us angle side angle. And that means that we can prove this. So we'll go ahead and put that down there. That's by angle side angle using lines 3, 6, 7.
Okay, class, we're on to our next proof. This is the next type of proof, as you can see. And first, like we did last time, you start with the given. And this given is that UR is parallel to segment ST, and angle R and T are both right angles. So first, we start off with the givens, which I've already written down, and then you have to say that angle R and T are congruent, and that is because all right angles are congruent. Next, you have to state that RUS is congruent to TSU because of alternate interior angles. this bisecting line, not exactly bisecting, but it cuts it in the middle, that you use the reflexive property on a line like that. So this means that US is congruent to US. And that is because of the reflexive property. Now you have enough to prove your proof. So you write down what you need to prove, or that since this is a different type of proof, you solve that the angles are congruent, and then you solve for the triangles. So triangle RUS, RSU is congruent to triangle TUS. And this is where you put the AAS, SSA, whatever it applies to it. And this one happens to be an angle side. And that is because of lines 2, 3, and 4. And since this is a different type of proof, you can't just solve out that. You have to finally solve out the final proof. And that is that angle RSU is congruent to TUS. And that is because of CPCTC, excuse me. And that is how you do that type of proof.
Okay, so this one's gonna be a little bit difficult. I got the others down. Now I have to do this one. We're given 4 givens this time, and right off the bat, we know that N's got to be a right angle because because NL is perpendicular to NQ, so we need that first. And also because it says right here that MP is perpendicular to NL, so that means that those are both right angles, which means they're both congruent. So here's what we'll do. We'll go ahead and put Q N M, angle Q and M is congruent to P M L, angle P M L. And that is if two lines are parallel, then they have to form right angles. So two lines are parallel, they form right angles. Yeah, I'll just abbreviate it right. Okay, and since we have that, we know that they're congruent because of the right angle theorem. So it's the right angle congruency theorem. And then, now that we have that, we can figure out that by M bisecting NL, we know that if M bisects NL, that those two lines have to be congruent, meaning NM and ML. So, we'll go ahead and put that. So, NM is congruent to ML. And that's by the definition of midpoint. Def of midpoint. And then for 8, since QMN is congruent to Q, because these are both parallel, and these are both right angles, and these are both equal. That means that this angle has to be the same because of the corresponding angle. What they do is they postulate, so we need to go ahead and put that down. So angle Q M N to angle P L M because of corresponding angles postulate. Let's abbreviate. So, I mean, it's gotta be angle side angle, because there's one angle, then we have our second angle there, and then those are our sides. So, in QM, let's convert to triangle L because of angle side angle, and we know that because of line 7, line 8, and line 6. So line 6, 7, and 8. And I think that's all I have to do to defuse the bomb. This was the last one. Alright, I finished the proof. The bomb should be stopping, but it's not. I don't know, we only have 3 seconds left. Oh. Alright, I did it. Bomb has been defused.